Hi, I'm Steve Mierop, a Senior Solutions Engineer here at Lucidworks. And today we're going to talk about how we can improve the quality and responsiveness to your chatbot. Goals of today's presentation are going to be to understand semantic vector search at a high level and how it can be used in conjunction with the chatbot. We'll look at a practical application of how it might be implemented, and then look at a live example. So what is semantic vector search and how can it be used to augment the chatbot experience? Well, semantic vector search to start really uses advanced deep learning techniques to understand user intention in a more powerful, more relevant way. And what this does is it allows you to ask natural language questions and get an accurate answer back. So we use this not just with chatbots, but with enterprise search. We also use it with e-commerce to help eliminate zero search results. And really, because we could better understand users and what their true intentions are and what they're looking for, this helps eliminate as much traffic to call centers by empowering users to find an answer to their question on their own. One final thing it also does is it helps alleviate the amount of conditional logic that you might need inside of a workflow engine, a chatbot workflow engine rather. So we're going to be looking at kind of all these examples today. So what is semantic vector search? In short, super high level, it's a set of techniques for finding information or products by meaning, as opposed to lexical search, which finds documents by matching words and their variants. So if you're familiar with how the storage mechanism of a traditional search engine works, what typically happens is as we ingest documents, the words in those documents get tokenized, ran through a series of analyzers or handlers, and ultimately stored in an inverted index, which is similar in concept to an index in the back of a book. On the other side, we have dense vector search. Dense vector search will actually store words and phrases and these concepts by their relationship to each other. So for example, horse and animal might sit more closely together in n-dimensional vector space as opposed to another group of objects or entities like New York, Paris, or Beijing. And there's a really nice visualization that I like to go to a lot. It's project.tensorflow.org, and you could certainly go to this on your own. And this is a really simple way to view, in this case, 200-dimensional vector space and looking at it in 2 dimensions. So, a lot of the information is you can't see it, but a machine can interpret it and see it. So let's do a quick search for something like DNA. And what you'll see here is that when we do that query for DNA, we're going to see other concepts that are sitting by it and other words that are related, like genome, tissue, chromosome, for example. These are going to sit more closely together in this n-dimensional hyperspace. Whereas if we did a search for, say, Chicago, you'll see that it sits in a different section of hyperspace, of this n-dimensional space, and different words are closer to it, like Boston, Toronto, Jackson, Illinois, which is pretty neat. So it's a different storage mechanism, and it's a different way to encode meaning of what someone might be searching for. So how exactly can this help a chatbot? And to answer that question, it's really where you use it. So with a traditional or more of these modern, I should say, chatbot engines, they're essentially big workflows or state machines, you could think about them, where you as an administrator, as you're building this out, you would define a series of intents, and this is using Google Dialogflow's terminology here. And for each intent, you would map a series of what they call utterances or incoming queries from a user. So if someone says hello or hi or hey there, that would ultimately map to the welcome intent, and then it would follow a series of workflow steps, sending a response, maybe asking for more information. So let's say this is a hotel or hospitality workflow example. Someone might come in and say, when will my room be ready? Well, that utterance will be mapped to an intent, and that intent would then handle the rest of that workflow. So it might say, hey, I'll need some personal information to identify you, maybe the account you used or your phone number you used to book the hotel room. And then from there, that input parameter could then trigger a fulfillment request, most likely a web service call that would call a database or search engine, find that information for that particular user's room status, and then send it back. So this is all well and good. It works great if you know all of the potential utterances and all of the potential intents that someone may ask. And that's where things can get a little tricky because it's hard to predict ahead of time all the different combinations of ways to ask a similar question. And oftentimes, in a lot of these modern platforms, there'll be a fallback intent. And this is pretty much the catch-all. So it's where someone asks a question or they use an utterance that I didn't define ahead of time, and the workflow engine doesn't know what to do with it. So what'll happen is it'll trigger a fallback intent, and then there's a number of things that you could do to handle that. You might say, hey, here's a number for help desk. You can call them and get more information, or here's a link to our FAQ section. You could check it out, maybe find your answer there. And it's okay, it's not a great user experience. So where semantic vector-based search comes in is this is a more intelligent way to help map an incoming question or query to what we actually have inside of our search index, which is ultimately in a vector representation. So how it works is we typically would take, in this case, we're using a pre-trained model, a model that's been trained across public available information across the internet for how people search and the different variations of the questions they ask. And what you can end up doing is you can encode that incoming query and then send that to a vector-based storage approach where you could do the information retrieval and actually see how closely that incoming query sits to content that you have inside of your search engine. So let's walk through a live example. And before we do that, I'll just show you, this is Google Dialogflow that we'll be using. I just took a quick screen capture of it. And one thing to notice is that very few intents are used for this. So I have a welcome intent when someone says, hi, hello there. I have a fallback intent, which is going to be encoding that query with our vector-based model and then doing that kind of nearest neighbor or proximity search inside of our vector-based storage layer. And then I have a status intent that's just anticipating if someone were to ask, when will my room be ready by? But even with just a few of these intents defined, what I want to show you is that we can ask a lot of different types of questions that I did not anticipate, and I didn't put the work in to configure a particular intent for. So for this, let's move over to the demo. And this is going to be a hospitality hotel type of experience where we're going to be interfacing with a fictitious company called Hotel California. And I'm going to walk you through the first part of that workflow. So let's start by saying hi. That triggered our welcome intent.
Welcome to the Hotel California. How may I help you today?
And again, that was pre-written by me. So that was part of our anticipated response. And then let's say, when will my room be ready? And again,
you got it. Please enter your phone number and I'll check on your room status.
This utterance triggered the room status intent. And now it's asking for some identifiable information. In this case, we triggered it to use a phone number. And from there, that phone number was fulfilled, probably web service call, went to a database or a search engine, looked up the status of my room, and then delivered it back.
Your room will be ready by 4 p.m. today. Can I answer any questions about the hotel for you?
Now, here's where semantic vector search can really help. It's in these fallback scenarios where it says, can I answer any questions about the hotel for you? Well, maybe I can't anticipate what's going to be asked, but I know I have a lot of attributes about the hotel, characteristics. I have frequently asked questions. I think I have about 100 or so inside of our semantic-based vector storage layer. So all of those have been encoded, and I'm just going to let the fallback strategy do the lookup for me. So I might ask, is there a fitness center in the hotel? And we'll get a response back.
Fitness center with 40 plus pieces of new life fitness equipment and spa are included. Both have accessibility options available.
Now this one is pretty easy, right? I said fitness centers here. We really don't even need semantic vector search for that. That could just be a keyword-driven approach. But where semantic vector search really shines and where the value is what if someone asks, what if someone asks this question in a different way and they're ultimately looking for this answer? What if they came in and said, can I work out here? You know, in that case, kind of just like our n-dimensional vector space model we looked at before, well, workout and fitness center probably sit pretty close to each other. And then we could use that as a way of establishing what is the nearest or closest or most likely answer to a question. So, and again, I don't have the word workout in my index. I don't have it, really, there's no rewrites, there's no synonyms defined for it. It's just all coming from that pre-trained, generally trained vector model. So let's try a couple more examples here. Maybe instead of can I work out here, I might ask, something a little verbose. Is there a place to do ab crunches in the morning? And again, conceptually the same. Hey, there's a fitness center. This is probably what you're looking for. And I could use fitness center. I could use workout. I could use ab crunches. I could say something like, where can I do bench presses? Maybe there's a nearby gym, or hey, maybe there's a fitness center in the hotel that I could use. So, handling these various permutations of how someone can ask the same question is really where semantic vector search can pull its weight and help you solve this kind of zero search results type of problem. And this is a better experience too, because now I don't have to redirect them to a help desk or somewhere else. I can empower that user to answer their own questions just using a pre-trained model. So, and this could also handle things like misspellings, auto vocabulary words like we've seen here. Maybe a more common question might be, can I bring my dog with me? And then we'll get a response.
Pets such as dogs and cats are not allowed at this property.
But what if someone came in and said, can my service animal stay in the room? Now there might very well, we could have created a new question dedicated for service animals, but let's say that I didn't. It was still smart enough to know that service animal is related to pets such as dogs and cats. Or if I said, can I bring my German Shepherd with, and we'll still land on that pets such as dogs and cats, and we'll get the appropriate response back without me having to predefine German Shepherd, without me having to anticipate this type of incoming utterance or question from a particular user. So really powerful stuff and really neat use cases that you could use to kind of close those gaps with things that where you can anticipate what could be asked. So I just wanted to leave you with this one other thought too. It's that putting the semantic vector search engine kind of at the center of an organization, well, there's some value in doing that. One is that you could keep your chatbot frameworks a little bit more lightweight and have more predictable, consistent results across these various user interfaces. And it's not uncommon for larger enterprises maybe to have one department using one type of chatbot and then maybe another department with their own resources and their own teams. They may want to build their own chatbot with a different framework. But with this approach, you could still feed from the exact same knowledge base that's been encoded and that's living in n-dimensional vector space. You could also serve third-party apps, intranet portals, e-commerce. A really big use case is eliminating zero search results in case someone submits a query about a brand that I don't carry, but I could still map it to a brand that I do carry and then present that to the user. So a lot of value of using a centralized storage mechanism for dense vector search and information retrieval. So, okay, thank you for joining me today. And any questions, feel free to submit an email or check out our website. So thanks again. Take care.